Hello, Algebra 2. I wanted to take a quick minute here to kind of go over the process once again and just focus on the process of how I look at these problems when it comes to LFR7, solving systems of linear equations, and how I make the decision of which one to use. We'll start with number one. Number one looks like a fairly familiar form. We've got y equals something times x plus a number or minus a number. This looks a lot like y equals mx plus b because it is. And because these are both in y equals mx plus b, I'm immediately going to go to graphing. So when do I go to graphing? So when do I choose to graphing? So if I see it, if I see it in, let's see, slope-intercept form. If I see it in slope-intercept form, I'll immediately go to graphing because that'll be pretty quick to do. I know you could do elimination, you could do substitution as well. Don't get me wrong, but when you're trying to learn the methods and I'm trying to figure out which one to graph, this is when I go for it. Slope-intercept form, maybe in point-slope form, because I can have a point and a slope. And then how about if I can efficiently determine, how about, there we go, intercepts. Right? That goes back to LFR2 when we found the intercepts and graphed using intercepts. If the numbers work out pretty well, like if they're all divisible by the same thing, they're going to come out nice and even, I would really think about graphing those. So again, that is how I think of graphing. In the case of number two, what I look at and see is I've already got one variable that's solved for in one of the equations. And that makes my job easier when I do substitution. And I say that because if I look right there, I've already got the first step done. Solve one equation for one variable, make it easier on yourself. And that's already there, right? It's already there. So with that said, I would go right to substitution. So anywhere I see x, I would instead put -4 plus 4y. Now I'd put it in a parentheses, and I'd put it in a set of parentheses and distribute the 5, because the 5 is going to the entire x, not just to the -4, but the -4 plus 4y. So that's how I would come up with substitution. In the case, I'm going to skip to number 4 real quick. I'm going to skip to number 4. Now, there's many ways to do this, but the way it's set up right now, I would do an elimination method. I would do elimination. And that's because I see, as it sits right now, I could just add these two equations together and get rid of y. I see that I can efficiently do that. That is what I'm looking for when I'm evaluating how I want to approach these problems. I would definitely take elimination. Could you do substitution? Yeah, absolutely. Solve one of them for y or solve for x. I would solve the top one for y, then plug that all back in. But I think in this case, elimination is still more efficient. Could you graph them? Yeah, solve for y, or figure out the intercepts and graph. You could definitely do that too. You could absolutely do that too. But my bet, I wouldn't mark you wrong if you did that, but in my opinion, elimination would be the most efficient way to do this one. Again, I'm just trying to make sure you can do all three of the methods. Number 3 is an interesting case. I could make a case for really any of these things. I could really make a case for any of them. I could make a case for substitution. I could solve for y and plug that in down in the second equation. I could solve for y in the first, plug it in for the second. I could graph, I could solve each of them for y, get slope-intercept form. I could also make a case for elimination, because what I could do, I could multiply. Let's say I wanted to get rid of y. If I multiply this entire top equation by 3, I'd have -4 equals -3x plus 3y. -9, oops, this is -12. Hopefully you caught that. -12 equals that. So -9 equals -4x minus 3y. And I'm right back to like number 4. I have an efficient way to do elimination. Or again, if I wanted to do substitution, I could solve that top one for y. Y equals -4 plus x. plug that into there and solve. I could solve both of them for y and get slope-intercept form. Again, it is up to you which method you choose, but I just wanted to take a minute and share with you my thought process that I go through when I'm deciding how I want to solve these problems. Hope that's helpful. Take care. Have a great day.